given this problem statement, the value of L such that the sum of the squares of the roots of the quadratic equation, that is given as x square plus 3 minus L times x plus 2 is equal to L. It has the least value. So the value of L we need to compute here. Now, based on the constraint. Now, given this quadratic equation, so given quadratic equation is this one, right? So I'll just replicate this part, and then in this equation I will subtract L on both the sides. So this will be effectively will be 2 minus L, and here I can write 0. Now if I compare this with the standard representation of a quadratic equation, which goes somewhat like this: ax square plus bx plus c, that is equal to 0, where a is a is not equal to 0. So if I compare with that, so the coefficient of x square is 1, the coefficient of x, that is 3 minus L, and the constant part, that is 2 minus L, which can be effectively said as the coefficient of x power 0 in the quadratic expression, right? If you just observe the left hand side part of it. Now I'll just assume this equation as equation 1. Now here let this equation 1 has the roots, that is a and b, right? So from this we can write the sum of roots, that is a plus b, that is equal to the coefficient of, that is negative of coefficient of x, that is 3 minus L over here, and from this I can write here 1, that is the coefficient of x square, which is effectively written as L minus 3. Now the next one, that is the product of roots, that is equal to constant term over coefficient of x square, so that can be written as 2 minus L as it is. Now with this given points, I'll just proceed ahead and try to compute this least value, that is I'll try to establish the relation for this sum of the squares of the roots. So for this, now for the sum of the squares of the roots, so square a square, one root is taken and squared, and the next root is taken and squared, and we need to find the sum. So a square plus b square can be written as a plus b whole square minus 2 times ab, right? So this is the standard identity. Now I'll proceed ahead with this one. So let me just replicate this part, and here the sum of roots, that is computed as L minus 3. So for this we can write L minus 3, and for the product of roots we have computed this one as 2 minus L. So this would be 2 times 2 minus L. Now on resolving this one, we'll be getting L square minus 6L plus this will be 9 minus 4, and here positive 2 times L. Now on resolving this one, we'll get L square minus 4 times L. On taking this minus 6L plus 2 times L, so 4 times L plus 5, and now this 5 can be written as 4 plus 1. The reason is, if you can observe this term, if you can observe this part, so this part can be written as L minus 2 whole squared. So if you can check, this is L square, this is 2 square, and then minus 2ab, that is minus 2 times L plus 1. Now if you observe this expression, since this value L minus 2 whole squared, it has to be greater than or equal to 0 for the real values of L, right? So in that case, the minimum value of this expression, that is a square plus b square, that is the sum of squares of the roots, right, is 1, and this is achieved at when the value of L is equal to 2, and hence from this we can say the answer to this particular statement, is 2, and hence this is the solution and the answer as 2 for this given problem statement.